In this video, we'll apply what we've learned so far about sum and difference identities to look at some applications. Example, let the pressure P in grams per square meter exerted on the eardrum by two sources be modeled by the functions P sub 1 of t equals 5 times the cosine of 440 pi t, and P sub 2 of t equal to 3 times the sine of 440 pi t, where t is time in seconds. We're being asked to graph the total pressure, which comes from the sum of that P sub 1 and P sub 2 that we just saw. And we're being asked to do that in a certain viewing window. Let me go ahead and graph this so you can see what those numbers in the viewing window mean. So here is a graph. Let's start out with first, what is this graph of? This is the graph of P sub 1 plus P sub 2. P sub 1, remember, was 5 times the cosine of 440 pi t, and we're going to add that to P sub 2, which is 3 times the sine of 440 pi t. Now, what is this viewing window all about? Well, this viewing window says that along the x-axis that I'm going to go from negative 0.01 to positive 0.01. And my steps, my increments, are going to be increments of 0.001. So each one of those steps along the axes is 0.001. On the y-axis, or in this case, I guess it wasn't an x-axis, was it? It was a t-axis that stood for time in seconds. Along my vertical axis, it said to go from negative 8 to positive 8 and to jump by ones. All right, so that's what that means. Okay, so we graphed the total pressure, and let's go to the question. The question says, use the graph to estimate the values for A and K such that P is equal to A times the sine of the quantity 440 pi t plus K. All right, so A is my amplitude, isn't it? A is my amplitude. So from the midline, what are the extremes? Well, it looks like the midline is occurring at that horizontal axis. So what we're talking about for the amplitude is the height. How tall and how low does this graph get? Now, the points have been labeled for me, and it's that second coordinate that gets me the height. So it looks like my A value, or my amplitude, is 5.831. Now, my K value is actually the phase shift. I need to find out what the horizontal shift is. This is a sine function, isn't it? This is a sine function. And we know that a normal sine function is going to hit its midline at the origin. It's going to hit its midline at the origin. This one is hitting its midline just a little bit to the left, isn't it? Hitting it just a little bit to the left. And so we're going to say that we could rewrite this P equation as P equals the amplitude 5.831 times the sine of 440 pi times the quantity. And I didn't give myself enough room, did I? Let me just erase this and write it down below. Let me put it here so I've got actually enough room. So P is equal to 5.831 times the sine of 440 pi times the quantity t. Now I'm moving to the left, so I'm going to say plus, and that shift, it looks like, is, do you see what this says here? It says negative 0.000745. Well, I'm just going to use plus 0.000745 because the movement to the left takes care of that negative. Now, what is my k value? My k value is going to be whatever 440 pi is times 0.000745. So if I simplify this one step further, I get that P is equal to 5.831 times the sine of 440 pi t plus, when I put 440 pi into my calculator and I multiply it by that 0.000745, I got 1.029814072, which I'm going to round to 1.03. And that 1.03, that is my k value. So I have successfully, I think, solved this first part. I know what k is, and I know what a are. Now, there is a part B that we'll look at in just a second. On the last slide, you saw me graph P equals P sub 1 plus P sub 2. Now, I used Desmos to do that, and what you may have seen, or maybe you didn't notice it, but when I put it into Desmos, instead of using the t variable, I actually used x, and that is simply because that's what Desmos understands. All right, so even though that x was there, I knew that it was a t. Okay, so that's what we came up with for part A. We came up with, when I added and found A and K, that P was approximately equal to 5.83 times the sine of the quantity 440 pi t plus 1.03. Here comes the next part. Use a sum or difference identity to verify that P actually does equal P sub 1 plus P sub 2. Now, in order to do that, we're going to need the sum formula for sine. Now, why is that? All right, well, let's write this out. So I've got P is equal to 5.83. Now, that 5.83 is being multiplied by that whole sine function. I'm going to put a bracket on this because I'm really only going to be paying attention to the sign of the sum. The sum is 440 pi t plus 1.03. Okay, so in this example, we have an alpha, right? Our alpha is going to be the 440 pi t, and our beta is going to be 1.03. Okay, so here's what this is going to work out to be. I'm going to still have that 5.83. Actually, let me just move down below. Let me move down below. So this is going to equal 5.83 times the quantity, the sine of the first angle. Well, that first angle is 440 pi t times the cosine of the second angle. So the cosine of that 1.03. Remember, it wasn't exactly 1.03. I think we did some rounding on that. Plus the cosine of the first angle. So there's that 440 pi t again. And we're going to multiply that by the sine of 1.03. If I still have those exact numbers, of course, I'm always going to use them. Okay, now I'm going to grab my calculator again and just do some preliminary work here. So I don't know what the sine of 440 pi t is because there's that variable of t there, but I can put into my calculator the cosine of 1.03. So when I put the cosine of 1.03 into my calculator, there's no degrees on that 1.03, so I'm in radians. I got approximately 0.515. Make sure you get the same thing. Double check me. All right, plus I don't know what the cosine of 440 pi t is, again, because of the variable, but I can put sine of 1.03 into my calculator. And when I did that, I got, again, double check me, I got times approximately 0.857. Okay, so here's what I have. I have one term plus one other term, and on the outside I have a 5.83. So I'm going to take the 5.83 and I'm going to multiply it by the 0.515. When I do that, I get, it's hard to believe, but 5.83 times 0.515 is approximately 3. So I have 3 times the sine of 440 pi t plus, now I'm going to take 5.83 and I'm going to multiply it by this term, and 5.83 times 0.857 is approximately 5. So I get 5 times the cosine of 440 pi t. Now, I hope that those look familiar to you, because 3 times the sine of 440 pi t was simply our p sub 1, excuse me, not our p sub 1, it was our, let me erase this, it was our p sub 2, wasn't it? P sub 2. And 5 times the cosine of 440 pi t is our p sub 1. So sure enough, p really does equal p sub 1 plus p sub 2.